let's get this kicked off. So today we're gonna run through our workshop 2. I think our naming has maybe been a little confusing because we had an intro and then we have 3 workshops, but it's like workshop 2/3. So let's go with that. This running through this workshop is pretty straightforward, but illustrates a really important concept and how to work with Drosera and deploying traps and kind of the trap development life cycle. So this one should be pretty quick here, but so today, let me start. Yesterday, we deployed a new trap from scratch. It was the first time. It was not on chain, and we deployed it on chain. It was brand new. Today, we're going to update an existing trap. Right, we've also seen many people run into like a trap limit, like they can't deploy any more traps on chain because we do currently have a limit on testnet, and some people didn't really understand the concept that we can simply update an existing trap. You don't need to keep deploying new traps.
Let's touch on that one a little bit further too. I've seen questions where people say, okay, I made a trap, but how do I delete it, right? Well, just like hacks. Can't necessarily. It's kind of similar in that way, or when they're out in the world, we don't have like a way to remove them, and you don't need to make 100 traps or so. You can make even one trap for as many different things as you want. So that's really the point of this workshop, to help people understand how to reuse your trap. How do you update it? If some of you remember, a couple weeks ago, we asked people to reapply their trap, Drosera apply. And we actually saw super great participation from the community. And I think we're actually at the point where a lot of people have reran Drosera apply. So it's already awesome to see. But I don't think very many people understood necessarily what is Drosera apply doing when you do this update. So hopefully this sheds some light on that.
Okay, so essentially what we're going to be doing today is we're going to be, updating your trap. You could update it in a couple different ways. You could be updating the actual trap solidity code, which we'll take a look at tomorrow. Another way you could update your trap, which we're going to look at today, is not in the solidity code, but it's in your Drosera.toml file. Because one of the core things that the most important configuration pieces for your trap is if it does should respond returns true, then what is it supposed to go call on chain? And so that's your response function and contract. So this will also be considered an update. And these pieces of information are actually stored in the trap config contract that's actually stored on chain. It's not on the seed notice, it's actually on chain. So that is what we're going to be doing here today. We're going to update our Drosera.toml file to use the new some other response function that exists on a contract that's been deployed to Haleski, function signature, and new response contract address. Yes, and I apologize if I haven't posted this in a chat here for people to follow along. Hopefully you have it downloaded from yesterday already. There we go, I put that in the chat. Okay, so let's do this. This is the new function signature that we're going to use. So when our trap responds, it will call this function on this contract. And we have to make sure we get this exactly right. It got me the other day. For example, if you leave off the parentheses, even though this function takes no arguments, if you leave off the parentheses, that will cause it won't work because this whole thing gets hashed, catchjack 256 hashed, and then they take the first 4 bytes of that hash as a function selector. And so even one character difference will change the hash, and then it will say it doesn't exist on the contract, even if though you see there's a function called this. So pay very close attention, be very accurate with these, or you'll run into mysterious. Let's be careful with that. And we're going to get our response contract. I'm going to go into Workshop 2 here and go into our actual trap. And this has the response contract. This contract has already been deployed on Husky, so you should be able to use this.
Can you walk through what that trap is doing?
Yes. Okay, so in Workshop 2, if you go to the script folder, mock and mock response, here we can actually see, so this is not a trap. This is just a normal, wait, hold on. Yeah. This is not the trap. This is just a normal, normal Solidity contract that's been deployed. And so when our trap triggers, we're configuring it so that it will call some other response. Here we go, the end, right? So yes. And essentially what this is doing, this is keeping track of who has responded to this. So you can't spoof this. You can't spoof this one. You have to actually be calling. This has to be called with an account that has deployed a trap. So you have rewards address, and then let's see, address user. And then it's setting you as a response to true that you responded with your address. So we can test later, passing an address in that you actually responded. So this is just a simple response contract demoing. This could be anything. This could be a Uniswap LP pool, for example, that you're responding, and then we're able to show that the state of the contract did in fact change after the trap was triggered, to show that the trap actually called this response function. So some other response function, that's what we put here. So it's going to call this, and then I need to set this contract properly. So in my Workshop 2 Trap.sol, here's the address of the already deployed on Husky contract, and I'm going to update my response contract right here. Okay, and from yesterday, I still have stuff set up. I still have my operator that I'm going to be using. That's whitelisted. And again, to drive home the point, this trap, I already deployed it yesterday, so it has an on-chain address, and now I can continue updating it, and it will retain the same address. Okay, I also want to change the path here. Where is the actual compiled Solidity code of my trap? And so yesterday we were doing Workshop 1, so that was there. Today I'm going to change the code as it's different now. So it's in Workshop 2. And that reminds me I need to, before we deploy this or update this trap, we need to make sure our code is compiled. So we have the easiest commands are out here in the outer README. So I'm going to run make build Workshop 2. Copy that. Okay, there we go. In the top level of the Drosera Workshops folder where you can run all these commands, we're going to run make build Workshop 2. Okay, I think maybe I've run this before and everything is already compiled. So should be good there. But if this is the first time you're doing it, then you'll probably see this a certain number of files were compiled. Okay, fantastic. Back into Workshop to README. Okay, so let's just test our trap is working locally. This is really testing for things like runtime errors, and it'll make sure with Drosera dry run that we are able to execute one full life cycle of the trap, like think like one block's worth of execution for the trap. So, Drosera dry run, okay. And Drosera dry run, so just to drive the point home, I'm in the top level of this Drosera Workshops directory, which has a couple different traps here in these different workshops. But because of my Drosera.toml, I pointed it specifically at Workshop 2. This is the compiled Trap 2 trap for Workshop 2. This is what it's actually going to be dry running and using all of these configurations. Okay, Drosera dry run, collecting blocks. Okay, my trap, we have a successful execution. It responded true. And let's just go take a look at this trap, because I haven't actually looked in here yet. We looked at the mock response, but let's look at the actual trap itself. Okay, I think this is the same as it was yesterday. So essentially, it's going to the response contract, testing if it's active. So the collect function just getting this one piece of state data, it's this one boolean, and then it's returning that as bytes. And then because our block sample size is set to 1 currently, that means that any operators running this trap, they will call collect one time, matching this. They'll call that one time, and then they will pass the results of that to the should function. And so we decode this data point as a bool. It was encoded as a bool. We decode it as a bool here. If the response contract is not active, we're going to return false with no information. But if the response contract is active, we're going to return true with no bytes, no information. And this is what would get passed into the arguments of the response function, this one. Now this one doesn't take any information. So we're not passing anything at all. And so when it's true, that means it's going to go execute this. Given that all of the operators in the operator set running this trap come to a 2/3 majority consensus. Now in my case, I'm going to be running the only operator, so if I come to, then that's going to be, I'm running in God mode basically. So, okay, that covers that. All right. So yeah, we got a true, so that tells us the response contract that's on Haleski. It is currently active, and then again, we returned no data. Okay. So let's run to the next. All right, so now we're going to run Drosera apply, and this will actually, it's going to go update our trap. Okay. It's running through so it runs through dry run to do another test at first. Then it creates a plan. Sorry, that's still dry run. Then it creates a plan. And I want to specifically note, different from yesterday. Yesterday it was, I believe it said create plan for my trap because it was a trap that didn't exist, so it was being created. But today, and it has an address, so it already exists. So it is updating an existing trap. Now to break some of these down, we trap hash changed? Oh yeah, so it's a slightly different trap code. So the trap, if you change the trap at all and recompile it, the hash of the trap code will change. Okay, I changed the response contract. This was the address I used in Workshop 1, and here's the address we're using today. And again, just to really connect the dots here, this address 4B98, that's what we have here, and that is what we have right here as the response contract. Okay, also I changed the response function, right, and now we're using the some other response function. And the seed node DNR, this changes, it doesn't look like it's changing, but things in the middle here are actually changing. We're shortening it because it's really long, because it may change seed nodes based on what is the optimal seed node at this present time. And currently doesn't require any Dro to do creates or updates, just for testnet purposes at the moment. All right, so let's run of course. We want to apply these changes. We're submitting our transaction to Husky Ethereum. Usually the loading bar is pretty close to accurate. All right, cool. So we updated our trap config, our address, this 1F89. Yep, it's still the same. This doesn't change between updates, stays the same. Okay, so now that's running, but as I discussed yesterday, deploying the trap or updating the trap, that's not enough for it to be executed. So we actually have to run the operator, and the operator is already should already be opted in from yesterday because we opted into trap address, and addresses don't change. So I opted in yesterday, so we should be good. Today we don't have to opt in. But first I'm going to go double check the response contract to check if I respond to a false because my operator's not running. Let me find my command in here. One second. That 4B98. Okay. I think I have it. Okay. So I'm going to run this cast call. This is going to the contract 4B98, which is our new response contract. So I'm going to test the response contract. It's going to call isResponder, and it's going to pass in the address that I used to deploy the contract. So we should see that I haven't responded yet because this trap hasn't actually executed. Submit submit this some other response function. So I get false. I haven't called it yet. So now I'm going to spin up the operator, and we should see that the trap will get executed because the response contract is active. So should respond, should return true. And then I can run my cast call again here, and I should get it true that I haven't responded. So let's spin over here to the operator, clear this, and so also yesterday I'm using the same keys for all of this. So I already had registered my operator yesterday. I already opted in to this trap. So now I just need to run the operator. So let's hit make run operator. Make run operator. Okay. We can see right here, number of opted in traps 1, which is as expected. So it's going to run through a little bit of a boot up start sequence, and then we should see something here pretty soon. Okay, starting to generate some attestations. And there we go. All right, this is the important part. Successfully submitted claim. And we can see it reached the signature threshold to execute the trap because we have the minimum number of operators set to only one. So even though I'm the only operator, I'm able to successfully come to consensus all by myself. And so we saw that the response function returned true, and so we submitted the claim, which goes and tells the on-chain trap config. So if I go back over here and I call my cast again, I should see that is responder is going to return true instead of false. So there's a whole nother life cycle of trap development, deployment, and execution. So pretty straightforward. So you really just need to, you can update your code and then recompile, or update your Drosera.toml, and then you just have to run Drosera apply again. It's an intelligent command. If it's a new trap, it will create the trap. If it's an existing trap that has an address, then it will simply update the trap, and the address doesn't change. And then you can continue updating pretty much as you want. So yeah, that pretty much covers it for workshop 2. And I guess we can take some questions.
Could you show? Could you go and show them how you can find your trap on the Trap Explorer?
Good point. So what I'm gonna do here, this address here in my Drosera.toml, this is what identifies my trap. This is the address of the trap config contract that's actually on chain. So I'm going to go to the Drosera Explorer here at app.drosera.io, and I'm not using a key that I have in a wallet that I can connect here. If I did, I could connect my wallet and there would be a button that's, I think it says it's like traps, my own traps or something like that. You can just click on that. But if you're using another key pair that you don't have in any MetaMasks, etc., then you can literally just copy the address from here and just come paste it into here, and voila. Here's my trap, and okay, and I don't even have the liveness data working. But this is because I'm running an operator locally, which requires some extra steps and have to open ports, etc. And I haven't done any of that stuff. So that's why
So if you guys are running your operator locally and you try to go and find your trap by looking for it in the Explorer, you'll at least be able to see, you have your operator opted in. And if you don't have any ports open, then yeah, you're not going to get liveness data, but that's okay. Liveness data is mainly for just being able to see results from your operator from the front end. Here, you don't need to worry about it. A lot of testing that we do, we tend to spin up operators locally, and we don't worry about liveness data. The only time we care about liveness data is if we're really just like some additional testing is not necessary for these workshops. Perhaps in the future we'll do a workshop where we can show you guys how you could get liveness data, so you can get those green blocks. But for this specifically, and that you can actually just perform the response function, you see that transaction gets submitted on chain, and that special cast call that Jake was running to go and see if the operator responded and it shows true is the thing that you would want to verify to make sure that your settings are
Yes,
all
I know
properly set up.
yesterday, Bobby, you made the point that red blocks on the front end doesn't mean the operator isn't actually like properly successfully running your trap on the back end. And so this is a great place for me to demonstrate that. We're just getting solid red blocks here on my trap, but I'm running the operator rightfully running for block after block after block. So should respond is executing successfully, and we got a true value for block number 3 million, blah, 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 right? And then again, should respond true for a further block number, right? 84, 85. So it just keeps going. So this operator's executing just fine, and it's doing all the stuff, and it still can call the response function on chain. And this is really just a minor thing. Um, so yeah. And then also, yeah, just a last point here. We can see, you can see elements of your Drosera.toml configuration here on the front end just to connect dots. So the minimum and the maximum amount of operators, right? So I'm running here just one of the minimum. The response contract, what's the block sample size for the trap, what's the cooldown blocks, and here we can see our response function, some other response function. So all that comes through, and if the trap is private or not. If it's private, you'll get this little icon here. And then here is the actual wallet that created the trap, and this is the address of the trap config, which is the address used to identify the actual trap. And then if you bloom boost your trap as well, you'll see that here. Okay, one side thing I wanted to touch on. We have a brand new website. This was germinating for a while, but we finally got it out. Shout out to Edox, our great friend and engineer, for putting this together. So I'd recommend everyone go check that out. It really looks super cool, and we're super excited to have this out. So yeah.
Okay. Yeah, very cool. I was gonna go ahead and diagram some of this information a little bit to show you like more of a visual aid for how trap updates work and how response functions are connected to your trap and how response contracts are connected to your trap. Visual aids always help a little bit for you guys to understand what pieces are connected to what. So let me go ahead and share my screen. So I'll just bring a big scaly draw here. And let's kind of like break it down a bit. So let's make a big box here, and we'll call this big box Ethereum. Okay, you know, this is like the blockchain where it's storing all sorts of contracts and all sorts of different things. You could have, like, let's say, call this like contract 1, contract 2, right? Contract 3. And these can be any contracts that live on chain, right? Let's say this contract 1 has a function on it called set balance, right? And maybe it's taking like a uint 256. It's like an integer, it's a number, right? And then this contract 2, let's say it has something like pause, right? And this contract 3, let's have it say something like swap, right? Maybe swap an amount of tokens. So you have like another number here as input. Okay, so these are just like contracts that live out here, out in any kind of protocol. You know, contract 3 could maybe be like a Uniswap pool. Contract 1 could be like a custom contract that sets some kind of balance. And that address that you are seeing, the address field in your Drosera.toml would be like this contract over here. Let's call this your trap config contract, right? So this it's kind of the thing that you have deployed on chain. It's also the thing that receives updates for particular fields from your toml. So things like response contract, right? And response function. Those are things that you set in your toml. When you do a Drosera apply from your terminal, okay, let's say this is you. This is a Droseran, okay, and you run a Drosera apply. Call this Drosera apply. It'll go and it'll update different configurations. In this workshop, what we updated was these guys. It was this response contract and this response function. Okay. Originally, for yesterday, the trap that we made, it was pointing to, but just for example, it was pointed effectively at one of these contracts. So the response contract here would be an address that points to the address of this contract, right? So this would be like address equals 0x 42069, okay? And that same exact for response contract. And the response function is like this set balance, right? So I'd put like set balance uint 256, okay? And that's what I put in my toml, and I did a Drosera apply. It basically pushed this information on chain, right? This is what you had when we went and deployed it. And so you can technically change these. So you could say this contract 2 down here is 777, right? If I did a Drosera apply where I changed my toml, I changed the address of the response contract field, then I would actually change this here. But if I didn't change response function, right, then this would be incorrect because I would be pointing at this new contract. You can see this contract 2 doesn't have set balance on it, right? So it would be trying to call a function on a contract where that function doesn't exist. So this would fail, right? When the operator tries to respond, it will make the claim on chain execute this response function. If you want the response function, then this, if you want the functions on that you actually want to hit. Now this will work correctly. You can apply these at any time. Maybe even contract 2 has another function on it called like change admin, right? If I wanted to call change admin,
It is funny because I ran into this same problem yesterday as I was kind of talking about, but I just remembered that in an upcoming CLI release, I've added a new feature so that it won't allow you to make this error. Like it will literally check that it does exist before it allows you to
so
do this.
Kind of try to add some guardrails in place so that we can catch these mistakes in case you guys make them. Really, it's just trying to make sure that your Drosera.toml is set up properly for your trap. You want to make sure that it's configured properly to actually perform the end result, right? The end result of a trap operator's claim being made on chain and causing this function to get hit. So with the operator piece, that'd be like up here, if I had, my Drosera operator, right? This would be like my node. When that operator opts in, right, it's going to do an opt-in, then it will start running this trap, right? Once that opt-in happens, this guy will start running this trap here. And then if that operator, as it's like running, if it sees that should respond as true, then it will make a claim on chain. So let's say should respond as true. Let's just move this text out of the way. And that will basically go through this trap config contract, and it will go ahead and it will call that function here, right? The operator will basically see the response function that I need to hit. So when should respond is true, it'll go ahead and it'll call that contract every time that should respond is true, and you don't have like a cooldown. So it's like readily available to hit this stuff. And obviously, if you had multiple operators, right, call this like another operator. When should respond is true, then they will communicate with each other and they'll gossip and they'll say, hey, I got should respond is true for this block. And the other operator will say, yeah, I got the same thing. They'll come to consensus and chain. And that will cause this response function to be triggered. So that's effectively the flow here. And the only thing you guys really need to know about for even doing these exercises is obviously running that Drosera apply and making sure you have an operator that's opted in, and then it can perform that action for you. In this exercise, the way that we knew that the function was triggered was we actually called that cast call command, that check to see is responder, right? It went to see did the response actually happen, and it returned kind of already know that it executed it as well by seeing that big text log that was showing that a response was being submitted inside the operator information about the transaction being submitted on chain. That's another way that you can know, oh yeah, my operator ran the trap and performed the action. And then just another way is that cast call to see that the function was actually called on chain. So hopefully this kind of helps you understand that, and you can even do other interesting things, like let's say we actually have another contract, call this contract 4, and let's call it like router or route. Okay, and obviously if we want contract 4 to be hit, what do we have to do? We have to update that Drosera.toml response contract response function to the right contract address and the right function. Let's call this 1, 2, 3, 4 information. And then we have to also update our response function that we want to be called on that contract that we're pointed to the route function. So this route function, it could, whenever this route function is called, it could go and call pause. Or technically, this response function could call both of these, or it could call all three, right? And this is where you start to get into some really interesting stuff you can do on chain, because you can kind of connect contracts together, right? Because now you could have another contract that does something completely different. Say this has a gmits, like an event called gr. From pause, this could call gr. So you can start creating this kind of cascading effect of contracts being called and doing different things. for this workshop, what we did was very, very simple, right? We only called one false. But if you guys want to experiment with this stuff, this is a good way to kind of see how does this stuff work? How can contracts be connected? How do contracts call other contracts? So yeah, this is kind of important to understand if you want to know how traps work, how incident response works. Yeah, just basically how.
We got a great question here, Boba. How can we protect the response function in the target contract so that only our traps, but not other wallets,
Right,
not other
exactly.
traps, can
So
call it?
normally what you can have in Solidity is you can have like an accessor function or a way that says only this address can call this function. So let's say that you have a contract over here that's like this is like my emergency contract, okay? And we have a really important function on it that's called let's say um, like move treasury funds. Maybe because like an exploit is happening or something bad is occurring, right? So you could have this contract. It has basically an emergency function on it. Uh, you can in Solidity add a check that says only this function can be called um, if message.sender equals 0x and the name, the address of your trap config contract. So let's say the trap config contract, which is the address field in your TOML, let's call it 0x 555. Okay. So over here in this emergency contract, you would want to have it say if message sent sender equals 0x555. If this is the case, then only this function can be hit by the trap config contract. Because the trap config contract almost acts as like a relay for your responses. The operator is the one that triggers the response contract to go and call something. So these response or the main contract here, they would be hit by the trap config contract. You would specifically want to make sure they can only be hit by this config. It's getting routed through this config contract from this address. And this address can be anything, right? This is what gets deployed or created when you deploy your contract, and this address will always stay the same unless you're using a different trap. So if you just have this check, no one can just like go and hit this function. Obviously, you don't necessarily need to have this. Let's say if it was like a liquidate position function that is like permissionless, like anybody in the world can call liquidate position, then you don't need only the trap can hit that. It's just that anybody else can. That how these functions are shop. We don't have like an accessor that says only this to participate in these workshops. So instead, it's an open function for anybody to hit. The response function does have a check to make sure that it's a trap that is hitting this function and it's not just another account. So in order for these functions to be hit, you do have to use a trap to do. And there's some other nuances there, but that is like the simplest way to make sure that only your trap can hit that function. Yeah. Any other good questions in here?
We're seeing some people are running the workshop, using a VPS. They're getting green bars.
Yeah, running on a VPS. Also, guys, if you are running an operator on a VPS and it's opted into your trap, you don't necessarily need to run the operator locally. If you already have the operator that's like running out there, then you can simply do your Drosera apply as long as the operator is already opted in. And I don't need to do anything special with the operator if it's already running somewhere, if that makes it easier for you. But obviously, if you guys don't have a VPS or you're not paying for a VPS to run out in the cloud, you can just run it locally. And we have the commands in that workshop to run.
I have a question. Is it true that we can have several trap configurations in a single Drosera.toml file? I kind of want to just demo that, share my screen and demo that real quick, because that's a easy point of confusion. See if I can clear all that up. Okay. Can you see my screen?
Yep.
Alright, so we're back. I'm back here in the same Drosera.toml file. So I've just been working with one trap, but maybe you're gonna work with multiple traps, right? Different traps that do different things, and you can choose to manage them in different ways. You have some flexibility here. So how this toml file is structured is some general top-level information that's used at a high level, like how to connect to Ethereum level, and then within that you can have individual traps. So what I could do here, I'm not going to copy the address because that's unique to one trap. I can copy this whole section, and it's going to give me error because it's a different name. So what if I give it now? It's my trap 2. Okay, and then this could be, this is some other code, and then I could change the response contracts, and I can change all of this. All this stuff can be customizable. Or technically, maybe you have one trap that that does this multiple different places, right? So maybe you deploy the same code, but you just deploy it multiple times, and in each case, maybe it calls a function on a different contract. And so I could keep copying and pasting these, right? And so if the way it is now, if I go run Drosera apply again, I think I can actually just go ahead and do this. I added a second one here. Let me save it. So it's just going to go to the path here, but it's a new trap. So there's going to be a new trap config that are like separate entities. So if I run Drosera apply again, let's see what we got. And actually, just for demonstration purposes, I'm going to do no. Let me cancel this. Let me cancel that. What I'm going to do to really show an example, let me change, this won't change anything, but let me just change this to 5, for example, right? This isn't actually going to change anything for how it's operationally running at the moment. So now, I'm going to just apply. Okay, you see bars, it was like student traps. So now, the result of Drosera dry run here, we have 2 results, one for my trap and one for my trap 2. Okay, so they're both running the exact same facility bytecode because my path was good, then it would be running different code. But in this case, they're the same. And then what changes do we have to apply? Okay, so we have, for my trap, this one already existed, so it's just doing an update, and I'm updating the max number of operators allowed to run the trap from 2 to 5. But then for my trap 2, this one is brand new. So it's going to create with all this configuration, and then it's going to submit 2 transactions, um, one for each. Sometimes Husky is a little slow, but the block time is supposed to be 13 seconds.
Yeah, sometimes if you are waiting here, it's simply waiting for the transaction to be confirmed.
Okay, there we go. One's through, now we're in the second one. Okay, and then we have our results. So we updated my trap. This address still stays the same. And then we created my trap 2, and here's its new address. And then if I come back here, now I can see that the Drosera CLI automatically added on this line at the end for my trap 2, and this is its address. And again, I can copy and paste this and search here, and here's my trap. And this one, so this is all the same. If I go back, you can see this one has no operators. Amount of operators on this trap. No operators, because this is a new trap with a with a unique address. My operator is running, but I never went and ran the opt-in command for this address. So if I added this one to opt-in with this address, then the operator would be running both of the traps. So I'm going to stop there, but I hope that actually significantly clears up some of this Drosera.toml stuff. And I guess last thing, you can put unique names, but if you prefer, you can also make different TOML files in different places and put like one trap per TOML file. You can kind of mix and match multiple. You could have one trap in one TOML file and in another folder. Then you could have a Drosera TOML with 6 traps, and so you can mix and match any way you want like that.
I'd also like to say that it looks like we are at 30K traps.
Ooh, wow.
So congrats, everybody. We added another 10,000 traps this month, it seems. It's like a solid 50% increase since last month. And we actually saw a lot of activity yesterday. I think we saw like almost 800 traps kind of paying attention and trying to run through these workshops and trying to create some traps. So thanks for everybody who's participating there.
Yep. Thank you, everyone, very much for showing up today and hopefully working through the workshop. Remember, if you actually are completing the workshops and executing response functions on chain, there's a Drosera role coming out for that. Kind of a one-time. So get it now while it's available. And we'll be back tomorrow for the final workshop.
Yeah.
In this.
Tomorrow I would say is probably the most important. Tomorrow is one where you can really put all of these steps together and kind of immortalize your Discord username on chain. And this will be really important for showing, which of you guys can actually run through these steps If you're doing tomorrow's workshop, the idea there is that we can see who actually deployed a trap and then had it push your Discord username on chain, and we'll be able to look at that to see who deserves the new role. So if you want to basically flex on people and show that you know how traps work, you know how to deploy a trap, then your opportunity is tomorrow to participate with us. And again, we'll have these videos, up on YouTube, so you can really run these workshops at any time. So you can always come back and show, hey, I ran the last workshop and got my Discord username pushed on chain. And you want to get a role, then you can do that at any point in time. So I just want to stress that tomorrow is super important for anybody who wants to get a special role for them to stand out in the community.
I'm definitely gonna go get this role.
Okay. I think that's about it.
Yep.
Yeah, thanks everybody for showing
All
up.
right, thank you. See y'all tomorrow.
See you, everybody.
You are.